Here is the combined summary. Croissant-RAI is a machine-readable dataset documentation format designed for responsible AI, building upon existing frameworks to enhance discoverability, interoperability, and trustworthiness of AI datasets. It extends the Croissant metadata format, incorporating attributes and practices for community-wide adoption, leveraging web publishing practices like schema.org and integrating into major data search engines, repositories, and machine learning frameworks. The format was developed through a community-led effort, focusing on evolving documentation requirements, and includes a Python library and a visual editor for user assistance. The development of Croissant-RAI involved a multi-step vocabulary engineering process, comprising bi-weekly sprint sessions, stakeholder engagement, and brainstorming to define use cases. This process included comparisons with existing dataset documentation vocabularies, scope definition through competency questions, and conceptualization of the RAI extension. The implementation involved bi-weekly sprint cycles to develop conceptual models and operationalize core features, followed by an evaluation phase involving annotating popular datasets to ensure effectiveness and usability. The Croissant-RAI format extends schema.org with additional layers describing datasets' attributes, resources, structure, and semantics, facilitating their use and sharing within the ML community. It addresses the need for machine-readable metadata formats in the ML community, enhancing discoverability, portability, and reproducibility of ML datasets. The format is crucial in developing fairer and more trustworthy AI applications by proposing a machine-readable framework for capturing RAI data documentation practices. The Croissant-RAI vocabulary is a novel approach to annotating AI datasets, focusing on ethical and societal implications of data collection, processing, and utilization. It provides a comprehensive framework for describing datasets in a structured and standardized manner, encompassing various aspects such as data limitations, biases, manipulation protocols, and annotator demographics. The vocabulary includes attributes for 5 use cases: data lifecycle, data labeling, participatory data, AI safety and fairness evaluation, and regulatory compliance. It is structured to be scalable to other domain-specific extensions in the future and incorporates both core Croissant and schema.org properties, as well as new properties defined specifically for the RAI extension. The vocabulary is demonstrated through 3 diverse datasets, including HLS burn scar scenes, DICE's 350, and Big Science Roots corpus, each with its unique characteristics and challenges. This schema encourages data authors to reason about their data with a specific schema in mind, providing a comprehensive understanding of the data and its implications for AI model development and deployment. The paper presents Croissant-RAI, a machine-readable format for capturing and publishing responsible AI, RAI, documentation metadata for AI datasets. This format aims to facilitate the sharing, discovery, and reuse of RAI information in datasets, thereby promoting responsible AI practices. The authors emphasize the importance of integrating RAI benchmarks into frameworks to foster higher data quality standards and encourage further research in this field. The paper also highlights the Big Science Roots corpus dataset, a large-scale multilingual dataset used to train the Big Science Large Open Science Open Access Multilingual (BLOOM) language model. This dataset has inherent variability due to its diverse sources, which can lead to inherited limitations and biases. The authors provide an overview of the pre-processing steps applied to ensure data quality. Moreover, the paper discusses several other datasets and tools that support the development of Croissant-RAI, such as the DICE's dataset for evaluating conversational AI safety, crowdworksheets for accounting for individual and collective identities underlying crowdsourced dataset annotation, and the FAIR guiding principles for scientific data management and stewardship. The authors also discuss the need for data-centric machine learning research, as well as the importance of navigating dataset documentations in AI. They mention various tools and initiatives aimed at promoting data quality and responsible AI practices, including the Croissant Python library and its web UI editor, which allows users to input RAI attributes in JSONLD form. In conclusion, the paper presents Croissant-RAI as a significant step towards enhancing the transparency and accountability of AI datasets. It highlights the importance of responsible AI practices and the need for high-quality datasets that can help mitigate system bias and foster better science. The authors emphasize the role of community engagement and collaboration with public and private partners to ensure the widespread adoption of RAI methodologies and their responsible implementation. The summary then delves into the data collection process, including types of data collection and descriptions of missing data. It then discusses data preprocessing, focusing on protocols for handling missing data, data manipulation, and data preprocessing. The importance of data annotation is highlighted, discussing various aspects such as annotation protocols, platforms, and considerations for converting raw annotations into labels. The section on data release maintenance includes versioning information, while discussions on personal sensitive information, social impact, biases, limitations, and use cases are also covered. Finally, the summary touches on the number of annotations per item, annotator demographics, and machine annotation tools used. Throughout, technical terms and concepts are explained with precision, highlighting the significance of each component in the data lifecycle.